Hi everyone, I am BASTATAS, and today we are gonna talk about the weather fronts. So sit back, relax, and enjoy my video. You may have seen weather experts on television talking about a warm front or a cold front arriving and bringing with it a shift in the weather. But what exactly is a weather front and how does it impact our weather? When a front passes across a region, it indicates that the weather is changing. Many fronts are responsible for meteorological occurrences such as rain, thunderstorms, strong winds, and tornadoes. Thunderstorms may occur along cold front. Low stratus clouds may form along a warm front. Once the front is gone, the sky is usually clear. What is a weather front? A weather front is a transition zone at the Earth's surface between two distinct air masses. Each air mass has its own temperature and humidity profile. There is often turbulence near a front, which is the boundary between two distinct air masses. Clouds and storms can form as a result of turbulence. Some fronts, instead of generating clouds and storms, can only create a temperature shift. However, certain storm fronts ignite the world's most powerful storms. Tropical waves are fronts that form in the tropical Atlantic Ocean of Africa's coasts. If the conditions are favorable, these fronts have the potential to grow into tropical storms or hurricanes. Over the course of many days, fronts travel across the Earth's surface. High winds, such as jet streams, frequently dictate movement direction. Mountains, for example, can alter the course of a front. So there are four different types of weather fronts, which is the cold fronts, warm fronts, stationary fronts, and occluded fronts. First, we are going to talk about the cold fronts. A cold front forms when a cold air mass pushes into a warmer air mass. Weather patterns can shift dramatically as a result of a cold front. They can travel twice as rapidly as a warm front. As a cold front approaches, the heavier or the denser chilly air pushes beneath the lighter or the less dense warm air, forcing it to ascend into the troposphere. Warm air lifted ahead the front generates cumulus or cumulonimbus clouds and thunderstorms as shown in the picture on the left, or the picture that has a letter A in it. Winds get gusty as the cold front passes. There is a sharp drop in temperature as well as heavy rain, occasionally accompanied by hail, thunder, and lightning. At the front, atmospheric pressure shifts from dropping to increasing. Following the passage of a cold front, you may observe that the temperature has dropped, the rain has ceased, and the cumulus clouds have been replaced by stratus and stratocumulus clouds or clear sky. A cold front is shown on weather maps by a solid blue line with filled-in triangles along it. As shown in the chart to the left, the triangles act as arrowheads indicating in the direction of movement of the front. On the chart, notice how temperature at ground level vary from warm to chilly as you approach the front line. Warm fronts. When a warm air mass pushes into a colder air mass, a warm front occurs, as illustrated in the figure to the right or the picture A. Warm fronts are frequently associated with stormy weather because the warm air mass near the surface rises above the cold air mass, resulting in clouds and storms. Warm fronts travel more slowly than cold fronts because warm air finds it more difficult to drive cold dense over the Earth's surface. Warm fronts occur often on the east side of low-pressure systems when warmer air from the south is pushed north. A warm front is frequently accompanied with high clouds such as cirrus and cirrostratus, as well as intermediate clouds such as altostratus. These clouds originate in warm air that is located high above chilly air. As the front moves across an area, the sky is thin and rain is probable. If the air is unstable, thunderstorms may form near the warm front. The surface position of a warm front on a weather map is indicated by a solid red line with red, filled-in semicircles along it, as seen in the map to the right or the picture B. The semicircles show which way the front is traveling. They are on the other side of the line from where the front is moving. On the map, notice how temperatures at ground level are lower in the advance of the front than in back. Stationary front. When a cold or warm front stops moving, it produces a stationary front. This happens when two masses of air collide, but none is powerful enough to move the other. Winds blowing parallel to the front rather than perpendicular to the front can assist it stay in place. A stationary front might remain motionless for days. If the wind changes direction, the front will begin to move again, becoming either a cool or warm front. Alternatively, the front may disintegrate. Because a stationary front separates two air masses, there are frequently variations in air temperature and wind on opposing sides of it. Along a stationary front, the weather is frequently overcast, and rain or snow falls frequently, especially if the front is in a region of low pressure. A stationary front is depicted on a weather map as alternating red semicircles and blue triangles, as illustrated in the figure to the left. Take note of how the blue triangles point one way and the red semicircles point the other. Occluded fronts. A cold front might arrive soon after a warm front. A warm air mass pushes into a colder air mass, which is the warm front, is subsequently pushed into by another cold air mass, or the cold front. Because cold fronts move quicker than warm fronts, the cold front will most likely surpass the warm front, so this is referred to as an occluded front. The cold air mass from the cold front collides with the cool air ahead of the warm front at an occluded front. As these air masses collide, heated air rises. Occluded fronts typically arise at low atmospheric pressure regions. Precipitation from cumulonimbus or nimbus stratus clouds is common near an occluded front. As the front passes, the wind changes direction and the temperature either rises or cools. The sky is generally clearer and the air is drier once the front has passed. So an occluded front is depicted on a weather map to the left as a purple line with alternating triangles and semicircles indicating in the direction the front is traveling. It begins at one end when cold and warm fronts join and finishes at a low pressure region marked with a huge L on the map. So again, weather fronts mark the boundary or transition zone between two air masses and have an important impact upon the weather. And that's it for the topic about weather fronts. Thank you for listening and I hope you guys have learned something. Goodbye and have a nice day!